So today we are going to talk about proving triangles congruent. And there are going to be 5 ways that we can prove triangles congruent. This sheet I gave to you guys completely filled out as your note sheet, and I'm just going to go through and fill it out and kind of explain each topic. Today we're going to be focusing on SSS and SAS, but I'm going to go over each one just so you have that to reference. Alright, so the first one is called SSS, that is side, side, side. And if we know 3 pairs of congruent sides in 2 triangles, then we know those 2 triangles are congruent. So if we have this side, it's congruent to this side congruent to this side, and then our third side are congruent. If we know that 3 sides in 2 triangles are congruent, then we know those 2 triangles are going to be congruent because of SSS. SAS is going to be when we have a side angle side. So that's going to also be in that order, side angle side. So if we have this side is congruent to this side, then we have an angle up top is congruent to this same angle over here, and then we have a second side that is congruent. So side, angle, side, side, angle, side. If we know 2 sides and an included angle, so it's like in between them, are congruent, then we know these 2 triangles are going to be congruent. Then we also have ASA, which is angle, side, angle. So if we have 2 angles and an included side, then we know those 2 triangles are going to be congruent. So if I have my first angle down here, these 2 bottom left ones are congruent. I have 2 sides that are congruent, and then a second angle that is going to be congruent, then I know these 2 triangles will be congruent. Then we have angle, angle, side. So we have 2 angles and a side opposite of them. So if I have this angle here, my bottom left again is congruent to bottom left angle over here. And then I have a second angle, so I'll go with this top one. And then we have this side here that's congruent. So if I have an angle, angle, side, angle, angle, side, so that's where that order matters. 2 angles and a side opposite of them, then I know these 2 angles will be congruent. And then the last one is going to be hypotenuse leg. We're not going to use this one too much, but I just wanted to quickly go over it. So if you have the hypotenuse in any one leg of a right triangle that are congruent, so hypotenuse is going to be across from that right angle. So if my 2 hypotenuse are congruent, and then legs are the 2 sides that make up the right angle. So if I have one leg that's congruent to the other, then these 2 triangles are going to be congruent. Alright, reasons that we know sides are going to be congruent. First and easiest one, it's given. So if something is given, then we know they are congruent. Definition of a midpoint. So a midpoint will create 2 congruent sides. So if I have a segment, with this being my midpoint, I know these 2 are going to be congruent. So if I have a midpoint and it forms 2 triangles like this, I know those 2 are congruent, something like that. And then reflexive property, a side is congruent to itself. So if you have a shared side between 2 triangles, it'd be something like this. That side there, it's a shared side and they're both congruent. Okay. And then reasons angles are going to be congruent. First, again, easiest one, it is given. Second one is going to be vertical angles. I know I talk about this a lot. Vertical angles are always congruent, so that's when we have 2 lines intersecting. The 2 angles across from each other are going to be congruent, always, always, always. Then we have alternate interior angles, alternate exterior angles, and corresponding angles. So if we have 2 parallel lines, must have parallel lines, then we know those angles are always going to be congruent. And then lastly, we have the definition of an angle bisector. So angle bisector cuts an angle in half. So if I have this angle here, and I know this is my bisector, I will have 2 congruent angles. Okay. And then just a refresher from yesterday. So CP, CTC, corresponding parts of congruent triangles are congruent. So if we look at these 2 triangles here, we have triangle ABC. ABC is congruent to triangle DEF. So we know the first pair of angles that are going to be congruent, angle A and angle D, first letter, angle A, congruent, angle D. Then my second letter is going to be B and E, so those 2 angles, B and E, are going to be congruent. these in. Okay, and then my third angle, third letter, C and F. So C and F are going to also be congruent. Then I want to go on and list my congruent sides. So my first congruent side is going to be side AB and DE. Same order here. And then we're going to go on to my next side, which is going to be BC and EF. BC, EF. And then the last side that's going to be congruent is going to be AC and DF. Alright, so we are going to first start by going into more detail with SSS, or side, side, side. So if all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, we can prove them congruent using fewer parts. So this one, we're going to use 3 sides to prove them congruent. This up a little. So if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are going to be congruent. So in this picture, we have ABC and triangle DEF. So if we know the first side, AB, is congruent to DE, and we know this by looking at our picture, my first side, so that's 1. My second side is going to be BC, is congruent to EF. Again, know that by the 2 tick marks there. So that's my second side. And third, I have AC is congruent to DF. And that's my third side. So if I have 3 congruent sides, then I can say that triangle ABC is going to be congruent to triangle DEF. So even though we didn't talk about any angles here, since we know those 3 sides are congruent, we know that all 3 angles are also going to be congruent too. So going on to number 1, sample SSS proof. So we are given PQ is congruent to ST. So PQ is congruent to ST. So we're going to mark that on our picture. We are also given QR is congruent to TR. So QR, TR. And then I know that R is the midpoint of PS. So R is going to be the midpoint of PS. So I'm going to go down to my proof. My first statement, PQ is congruent to ST. Reason for that? Given. Number 2, I have QR is congruent to TR. Again, given. And then I have R is the midpoint of PS. That is my third given statement. Now I have PR is congruent to SR. So this one here is congruent to SR. And we know that those two are going to be congruent because R is the midpoint of PS, so that will be definition of midpoint. And then lastly, I have triangle PQR is congruent to STR. And my reason for that is going to be SSS, because I know that 3 pairs of sides are congruent, so I know these 2 triangles are going to be congruent. So we're going to go ahead and skip ahead to SAS and go over that and go over example number 4 together. So side angle side, or SAS. If 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So for this one, we need to have a side, angle, and side, and then included angle means in between those 2 sides. So our first side, if we know side AB is congruent to side DE, there's our first side, so there's our S. And then angle, so we have angle B is congruent to angle E. And then the third thing we have our second side, BC, congruent to EF. And that angle is in between the two sides, so it's included. And we have our side, angle, side. We can then say that these two triangles are going to be congruent. So triangle ABC is congruent to triangle DEF because of SAS. Okay. Then we're going to go on to work a proof together. So number 4, I'm given JM is congruent to LN. So I have JM over here is congruent to LN. And then I have angle JMN. Angle JMN is congruent to angle LNM. Okay? And I want to prove that triangle JMN is congruent to LNM. So my first statement, JM is congruent to LN. That is going to be given. Angle JMN is congruent to angle LMN. Once again, given. Then I have MN is congruent to NM. So that's saying MN, this side here, is congruent to NM, that same side, that shared side. So if it is a shared side, that is going to be a reflexive property. So we know those two sides are going to be congruent because they're the same side. And then lastly, we have triangle JMN is congruent to triangle LNM. And we know those two triangles are going to be congruent due to side, angle, side. We have that included angle in between the two sides.